Hello everyone, I am Anirban Pratihar. This is our group project on wine dataset using NIME software. We try to make a model which can predict wine type based on their characteristics and properties. Let's begin by setting up our wine dataset. Our team used two CSV files, one for red wine and one for white, each with 11 chemical features and quality scoring range from 0 to 10. We used CSV reader nodes to import both datasets. Then we used column filter to exclude unnecessary columns, and by removing rows which have missing values, we clean our dataset. Then added a new column called type, tagging each row as red or white using a string manipulation node. This extra column helps group sampling visually and model wine type as a feature. Once labeled, we joined both tables, which is with a concatenate node. Now we have one unified data set, red and white wine side by side. Read for an analysis, ready for an analysis. For analysis, our data set, I would like to call my fellow mate Diksha Mato.
Thank you, Anirban. Now we will analyze the chemical properties by wine type using box plot. First, we compare the red and white wines. This box plot shows difference in chemical properties across types. We can interpret that fixed acidity is higher in red wines, median around 7.9 gram per cubic decimeter. Citric acid and chlorides are slightly higher in white wines. Total sulfur dioxide it's higher in white wine, around 150 milligram per liter, used to prevent oxidation. Alcohol range from 8 to 15%, with white wines showing slightly higher values. Then, if we see at wine quality and alcohol, here's your first big insights. Alcohol and quality are clearly connected. Wine score 7 or above typically have alcohol greater than 12%. White wine shows a stronger relationship, possibly due to their lighter density and aromatic profile. Alcohol contributes to mouthfeel, balance, and precise strength, a top predictor in machine learning. We can see an upward slope between them. Then, if we go to alcohol and density, this plot reveals a textbook physical relationship between alcohol and density. Density drops, alcohol rise because alcohol is lighter than water. Red and white samples follow the same slope, useful for normalization and identifying outliers in pre-processing. Does sweetness equal high quality? Let's find out. Quality scores between 5 to 7 span the full sugar range, showing no consistent trend. Wines with extreme sugar often score only 5 or 6. White wines display wider sugar visibility for maybe stylist preference, not necessarily for quality enhancing. Then we can see a scatter plot, wine quality and sulfates. Sulfates are usually for microbial stability. Let's see how they affect ratings. A slight upward strength. A wine with sulfates often score 6 or higher. Red wines lean towards higher sulfates, 0.6 to 1.2 gram per cubic decimeter. May assist in improving self-line, which correlates modestly with perceived quality. Another scatter plot, wine quality and total sulfur dioxide. The compound preserved freshness, but how does it impact scoring? White wine dominate high SO2 level, ranking up to 300 milligram per liter, but quality score remain mixed, suggesting SO2 is used for protection, not directly influencing the taste. Helpful for classification, not core predictor of sensory quality. Another scatter plot, wine quality and volatile acidity. The plot exposes a major case of low ratings, acidity imbalance. The volatile acidity greater than 0.7 gram per cubic decimeter often links to quality score below 5. Red wines shows a broader spread, sometimes exceeding 1.2 gram per cubic decimeter. We can see a downward slope curve. High volatile acidity introduce sourness and off aromas, directly impacting taste and quality perception. So we can say maybe there are some relationship between the chemical properties. To discuss that, I would like to call my fellow friend Amrita Bera.
Thank you, Diksha. Next, we continue the analytics part. Next, we turn to correlation analysis, quantifying how strongly feature influence wine quality, and save it in an Excel file for better understanding. If we go through the Excel file, we can see positive relationship between we can see free sulfur dioxide and total sulfur dioxide, and also fig acidity and citric acid, and density and sugar, and also alcohol and quality. This feature more together and indicating physical or chemical dependencies. Negative relationships are in between alcohol and density, and also volatile acidity and quality. Then sugar and alcohol, and also density and quality. This highlight trend of lighter wine tend to be stronger and cleaner in flavor. And then we have chloride as a supportive feature with sulfur and density. After suggest chloride might continue via chemical synergy rather than direct sensory impact. After all those correlations and impact of chemical properties on quality, one question arrive in our mind: do wine types differ in average score? For that, if we see the quality score by wine type, we can see both red and white wines average around 5.5. It is confirmed that wine type is not a driver of quality. It's the underlying chemistry that matters. We will treat type as a categorical input, but not use it is as a level of superiority. After all of this data analytics, we try to find out best prediction model based on our data set. To discuss that, I could like to call my fellow mate Akash Dotto.
Thank you, Amrita. Let's go to our ML model. After concatenate the dataset and analyze the properties, we use normalizer to scale all numeric features into the 0.1 range via x minus mean by max minus mean. Ensure features like alcohol 8 to 15% and sulfates 0.3 to 1.6 gram per liter carry equal weight in models. Then use one to many to convert the categorical wine type column red or white into binary columns type red, type white. Makes wine type machine relatable without employing numeric order. After that, we use number to string to transform the quality numeric labels into string categories. It's required because mod and some learners treat the target as a nominal classes. Then we use table partitioner to split data into 70% training and 30% testing sets. Ensures we evaluate and unseen data to gauge to the predictive power. At least we use mod synthetic binary over sampling technique to detect underrepresented quality classes like 0.166 and 0.833 in the training set. Generate synthetic samples in interpolatic features values between nearest neighbors of the same class. Balance classes distribution so models don't ignore rare quality scores. Then we trained our models to explain that I would to call our fellow mate Virud Guchai.
Thank you, Akash. So we trained 4 models as per our requirement. Decision tree for interpretability, random forest for ensemble robustness, SVM model for boundary-based learning, and PNN as per probabilistic neural approach. And we saved the result in Excel format. So, if we go through the Excel file, we can see random forest excellence across mid-range scores. 0.333 has 464 true positive values and 0.5 has 544 correct classifications. Few false positive than other models with high recall and F measures. Random forest had accuracy 63% and F measures 0.70, where SVM collapsed prediction into just 2 bins with low diversity. PNN predicted across all classes but with precision drop-offs, and decision tree worked well visually but lacked depth in class balance. At conclusion, we can say wine quality depends on its chemical composition, most notably alcohol and volatile acidity, with supportive effects from sulfates, citric acid, chloride, rather than on whether it's red or white. By applying min-max scaling and SMOT for class balance, our random forest model delivered the most accurate and reliable predictions. Thank you.